On the morning of September 15th, 2017, a spacecraft the size of a school bus became the only human-made object in history to physically touch the surface of Saturn. Not orbit it, not photograph it from a safe distance. Touch it, plunging directly into its atmosphere at over 78,000 miles per hour, sending back real scientific data for every second it could, right up until the moment it was torn apart and vaporized, becoming, quite literally, a small part of the planet it had spent 13 years studying. NASA didn't lose that spacecraft by accident. They aimed it there on purpose. And what it found in its final hours, and what its data has continued to reveal in the years since, including a discovery published as recently as this year, is still reshaping what we understand about the ringed planet. Tonight, we're looking at the true story of the only spacecraft that has ever touched Saturn, why NASA chose to destroy it deliberately, and why its final transmission is still teaching us new things nearly a decade later. To understand why this ending mattered so much, you have to understand what came before it. The Cassini spacecraft launched on October 15, 1997, and after a 7-year journey across the solar system, entered orbit around Saturn on June 30, 2004, carrying with it the European Huygens probe, which would go on to land on the surface of Saturn's largest moon, Titan. What followed was one of the most scientifically productive missions in the history of planetary exploration. Over more than 13 years circling the Saturn system, Cassini discovered a global subsurface ocean beneath the icy crust of the small moon Enceladus, complete with evidence of active hydrothermal vents on its seafloor, environments strikingly similar to the deep-sea vents on Earth, where some scientists believe life itself may have first emerged. It also mapped vast seas of liquid methane on the surface of Titan, the only other body in the solar system besides Earth known to have stable liquid on its surface, just not liquid water. Cassini's original mission was supposed to last 4 years. NASA extended it twice, stretching what began as a 4-year assignment into more than 13 years of continuous exploration. Think about the scale of what that extended mission actually produced. Cassini didn't just take a handful of memorable photographs and call it a career. It watched entire seasons change on Saturn and its moons over more than a decade, tracking shifting weather, patterns, storms, and the slow rhythm of an alien year lasting nearly 30 Earth years. It witnessed the birth of a small temporary moon forming within Saturn's rings, caught in the act of coalescing out of ring material. It flew directly through the icy plumes erupting from Enceladus's south pole, tasting the chemistry of an alien ocean without ever having to land. By the time its fuel finally began running low, Cassini had completed 294 orbits of Saturn and sent back well over 450,000 images. An archive so large that scientists are still combing through parts of it today, years after the spacecraft itself stopped existing. By 2017, though, Cassini was running out of fuel, and that created a genuine problem. A spacecraft with no fuel left can't control its own trajectory, which meant there was a real risk that an uncontrolled Cassini could eventually drift into and collide with either Enceladus or Titan, two moons NASA had specifically identified as potentially habitable environments worth protecting from any contamination by spacecraft material or Earth. Microbes that might have hitched a ride nearly 2 decades earlier. Rather than risk that outcome, mission planners made a deliberate choice. They would send Cassini somewhere no contamination could ever matter, directly into Saturn itself, a planet so hostile that anything reaching its interior would be destroyed instantly and completely. But NASA didn't just point Cassini at Saturn and let it fall. They turned the spacecraft's final months into an entirely new phase of exploration, one deliberately designed to gather data too risky to attempt earlier in the mission. Beginning in April 2017, following one last close flyby of Titan that flung the spacecraft's trajectory up and over Saturn's icy rings, Cassini entered what NASA called the grand finale, a series of 22 weekly dives through the narrow, roughly 1,500-mile gap between Saturn's atmosphere and the innermost edge of its rings, a region no spacecraft had ever dared enter before. Nobody knew for certain what was in that gap. Some engineers worried it might be filled with ring particles large enough to seriously damage or even destroy the spacecraft on contact. It wasn't. Instead, it turned out to be a genuinely valuable, largely empty corridor, and Cassini used its 22 passes through it to map Saturn's gravity and magnetic fields with a level of precision impossible to achieve from any orbit farther out. Each of those 22 dives carried real risk, and mission engineers treated every single pass with the kind of caution usually reserved for a spacecraft's most delicate maneuvers. Before the very first dive, the team wasn't entirely certain Cassini would survive its first crossing of that gap intact, and they deliberately oriented the spacecraft's large dish antenna to act as a makeshift shield facing forward, ready to absorb any unexpected impacts from stray ring particles during that first pass. When Cassini emerged from the gap, undamaged and functioning normally, it confirmed the region really was safer than feared and cleared the way for the remaining 21 dives to proceed as planned, each one venturing slightly closer to the boundary between planet and rings than the last. Then, on the morning of September 15th, 2017, the mission entered its final hours. Cassini's last orbit was arranged to send it directly into Saturn's upper atmosphere, and the spacecraft plunged in at roughly 78,000 miles per hour, or about 35 kilometers per second, its small thrusters fighting to keep its antenna pointed at Earth for as long as physically possible as atmospheric drag began tearing at the spacecraft. Its instruments, including a massive spectrometer built to sample atmospheric chemistry, kept collecting and transmitting data for every second contact remained possible. Within minutes of entering the atmosphere, radio contact with Earth was lost for good. Cassini burned up and disintegrated like a meteor, its material scattering into the very planet it had spent over a decade orbiting. What Cassini sent back during that final plunge, and during the 22 dives leading up to it, turned out to be worth the risk many times over. One of the most striking discoveries confirmed something scientists had suspected since the 1980s, but had never been able to directly verify, a phenomenon known as ring rain. As Cassini flew through the narrow gap between Saturn and its rings, its instruments directly sampled material raining down from the rings into the planet's upper atmosphere, confirming that Saturn's rings are actively, continuously shedding material into the planet itself. The composition of that falling material surprised researchers. Saturn's rings are roughly 90% water ice, but the material actually raining down into the atmosphere included a notable mix of hydrocarbons, methane, and sulfur-bearing molecules, a genuine chemical puzzle. Researchers are still working through. Separate measurements found that some of this material wasn't just being pulled in by gravity, but was streaming directly along the plane of the rings into the atmosphere through a process called atmospheric drag, carrying molecules and particles smaller than 2 nanometers across the gap in a way nobody had directly measured before. Researchers involved in the mission described the sheer quantity of material involved as one of the biggest surprises of the entire grand finale. For 4 decades, scientists had built theoretical models predicting that Saturn's magnetic field carried a slow, steady trickle of charged particles from the rings down toward the planet's mid-latitudes. What Cassini actually measured up close was a far more substantial, far more chemically complex flow than those older models had ever predicted, forcing planetary scientists to rethink not just how much material the rings are losing, but how quickly that loss might eventually reshape the rings themselves over cosmic timescales. It was, in the words of scientists who spent years studying the resulting data, a genuinely phenomenal surprise. The kind of discovery that could only have come from actually flying an instrument through the gap rather than observing it from a safe distance. Cassini's final dives also produced detailed maps of Saturn's gravity and magnetic fields, data precise enough to offer real constraints on the planet's internal structure for the first time. And that magnetic field turned out to hold its own mystery, unlike Earth, where the magnetic field is tilted noticeably relative to the planet's rotation axis. Saturn's magnetic poles turned out to align almost perfectly with its actual axis of rotation, an alignment so close that it's made measuring the planet's precise rotation rate, and therefore the actual length of a day on Saturn, unusually difficult, since scientists typically rely on a slight magnetic tilt to track a planet's spin. That difficulty didn't go away when Cassini burned up. It's still being worked out, using Cassini's own data, years after the mission ended. In 2019, researchers studying wave patterns hidden within Saturn's rings, essentially using the rings themselves as an enormous natural seismometer sensitive to vibrations rippling outward from deep inside. The planet calculated Saturn's actual rotation period with new precision, 10 hours, 33 minutes, and 38 seconds, finally pinning down a number that had eluded planetary scientists for decades. And the story didn't end there either. For years, separate radio measurements taken by Cassini seemed to suggest Saturn's rotation was somehow slowly changing over time, an apparent impossibility for a planet of that size. It took until March of 2026, using entirely new observations from the James Webb Space Telescope, staring continuously at Saturn's aurora for a full Saturnian day, for researchers to finally explain why. Powerful winds, high in Saturn's atmosphere, driven by its own aurora in a self-sustaining feedback loop, were generating electrical currents that distorted the radio signals scientists had been using as their rotation clock all along. Saturn's spin was never actually changing. Cassini's instruments had simply been listening to an atmospheric disguise nobody had the tools to see through until this year. That's the real legacy of the only mission that ever physically touched Saturn. It wasn't just a dramatic ending captured in a single dramatic headline. It was a final act of exploration that kept feeding new discoveries back to Earth for years afterward, through data still being reanalyzed, still generating new papers, still solving mysteries nearly a decade after the spacecraft itself ceased to exist. Cassini's final transmission wasn't really the end of the story. It was simply the last time the spacecraft itself got to participate directly in writing it. There's something worth sitting with in that. Most spacecraft missions end quietly, drifting into silence, as power fades or contact is simply lost. Cassini's ending was different, not because the spacecraft itself survived any longer than any other mission eventually does, but because its final act was deliberately engineered to keep producing science for as long as physically possible, right up until the atmosphere itself tore the instruments apart. And even after that, the data it managed to send home in those final minutes, combined with everything gathered during the grand finale's 22 preceding dives, has continued to generate genuine scientific breakthroughs for nearly a decade, with the most recent, the 2026 explanation of Saturn's shifting rotation signal arriving a full 9 years after the spacecraft itself no longer existed in any physical form. If you want to be here the next time Cassini's old data reveals something new about Saturn, subscribe and turn on notifications, because nearly a decade after the only spacecraft that ever touched this planet burned up in its atmosphere, its final gift to science is still arriving, one carefully reanalyzed dataset at a time.